Welcome to this video on the zero rule of exponents and the introduction to negative exponents. Let's begin. The exponent 0. By definition, a to the 0 power is equal to 1, and a can be any real number except for 0. Let's demonstrate this rule using a to the third power divided by a to the third power and applying the quotient rule. So remember, in a previous video, we learned that the quotient rule tells us that when we have something that looks like this, we can find the result by subtracting the exponents. However, 3 minus 3 is 0, so we get a to the 0 power. Let's consider a different way to approach this problem, which is to rewrite a to the third power as a times a times a, and then same thing down in the denominator. So notice, if I write it this way, all of my a's are going to cancel out, leaving me with not 0, but what? 1, right? Because anything divided by itself is 1. 1, 1, 1. Okay? So I have just demonstrated that a to the 0 power is equal to 1. Okay? So again, this is just something that you have to know or memorize or practice demonstrating. If you don't want to memorize it, at least be able to do something like this to remind yourself that it's true. So there is one exception to this rule. If you want, you can pause this video and guess what value that is. I kind of already sort of gave you the answer, which is that the base cannot be 0. So if we have 0 to the 0 power, we say that is undefined. Okay, and you can look up and research why that is. I'm not going to take time in the video because I want to keep going and introduce you to negative exponents. But there is a fun and interesting explanation for why 0 to the 0 power is undefined. Okay, so before we go any further, I want you to just kind of take a minute and pause and contemplate these questions. So my first question to you is, if you have something like 3 to the negative second power, okay, is the answer to this, right? In other words, I have a negative exponent. Is this going to give me a negative number or a positive number? So that's the first question I have. Okay? If it's not going to give me a negative exponent, then what does a negative exponent mean? And then I want you to think about, well, why do negative exponents exist? And I'll just give you a hint. It's not to make your life harder, because that's that's not why, although it might be true. Okay, and if you're not sure, think about evaluating or simplifying the following expression, which is a to the third power divided by a to the fourth power. So if you want to, pause this video, give yourself some time to kind of think about this. Don't Google it, don't look up the answers because I'm about to tell you, but just give yourself some time to process this and even make a prediction. Okay, because studies show that if you make a prediction, even if you're wrong, you're more likely to remember the correct answer. Okay, so here we go. I'm going to give you the answer. So if I'm actually going to start at the last bullet point, which is a to the third power divided by a to the fourth power. So as you know, I can approach this one of two ways. I can either rewrite the expressions as multiplication. So a to the third is a times a times a. A to the fourth power is a times a times a times a. Okay, and similar to the previous examples, right, we can cross out a's here. Okay, and what are we left with? Well, we're left with, in the numerator, 1, right, and in the denominator we have a. So we have 1 over a. Okay, so that's one way to consider it, one way to approach it. A different way to approach it is to apply the quotient rule, right? So I would have, oops, sorry about that. I would be able to subtract my exponents. Well, 3 minus 4 is negative 1, isn't it? So what does a negative exponent mean? Well, actually, a to the negative first power is not a negative number, is it? In fact, what it is it is a fraction. So a to the negative first power is 1 over a. Okay? So that is what a negative exponent means. So what if, let's go back even further, right? We have 3 to the negative second power. Well, how would I rewrite that? Well, I could use the same principle, right? So let's say I generate it by saying it's 3 squared divided by 3 to the fourth power, right? This is 3 times 3. This is 3 times 3 times 3 times 3, right? I think I said that the right number of times. If I didn't, please forgive me. Okay, Okay, so I cancel out those two 3's, right? What's left over on top? Well, there's 1 upstairs, and there's 3 times 3, or 9 downstairs, isn't it? Right? And again, right, the reason I picked 2 and 4 is because 2 minus 4 is negative 2. It's just one way to obtain 3 to the negative second power. So 3 to the negative second power is actually 1 over 3 squared. Okay, so what a negative exponent does is it finds the reciprocal value. Okay, so if something starts in the numerator, it's going to migrate to the denominator and vice versa. So this is like a pretty mind-bending concept. I know it's brand new. Okay, so it's going to take you a little bit of time to acclimate and to get comfortable with this idea. So let's just start slow. And we're going to practice applying the quotient rule so that we both get a positive and a negative exponent. So let's start in the left-hand column. So we have x to the 4th power divided by x to the 3rd, right? So again, we could write it as a multiplication problem, just like this, right? And we know that if I do that, then some x's are going to cancel out, but we still have 1x left over in the numerator, which is x to the 1st power. Again, we could also achieve the exact same result by simply subtracting our exponents. 4 minus 3 is 1. Okay? So let's turn our attention to this other example. We have x to the 3rd divided by x to the 4th. So again, if I rewrite it as multiplication, right, we're going to have 3 x's upstairs and 4 x's multiplied by themselves downstairs. So this time, notice what's going to happen, right? If I cancel things out, where is that extra leftover x? Well, it's not upstairs anymore, is it? It's downstairs. So it's 1 over x. Again, I could achieve the exact same result, well, a similar result, by subtracting my exponents. 3 minus 4 is negative 1. So let's just pause here and reflect on the fact that this and this are actually different, right? 1 over x is not exactly the same as x to the negative 1st power. So, heads up. Okay, in all of these problems, when you're working through these examples, the directions, which I don't have printed here, you just have to believe me, the directions are always going to ask you to write your final answer in using only positive exponents. So of the two expressions that I just circled, which one is going to get full credit? Well, the answer is this one. Okay, so if you get x to the negative 1st power, that's great, that's fine, right? But then what we have to do is we just have to apply one extra step, and we have to rewrite it as 1 over x. Okay, so that's what we're going to practice doing in a minute after we go through some more examples. Okay, so what if I have x to the 3rd power divided by x to the 1st power? So again, right, I could rewrite it as multiplication. These cancel out. I get x times x, or x squared. Again, getting the exact same result if I had just subtracted my exponents, because 3 minus 1 is also 2. Okay? On the other side, however, right, it's going to look a little different, isn't it? These x's cancel out, so we have a 1 left upstairs, so it's going to be 1 over x squared. However, right, if I try to do my quotient rule, 1 minus 3 is negative 2. Okay, these are equivalent expressions. However, remember, right, the directions are going to say express your answer using only positive exponents. So if I use my quotient rule, which I absolutely should because it's much faster, right, then when I get x to the negative 2nd power, I have to go one more step and rewrite it as 1 over x squared. Okay, let's do another example. So we have x to the 5th divided by x squared. So we have 5 x's upstairs and 2 x's downstairs. So we have 3 x's left over, and those 3 x's are in the numerator. Again, we could have achieved an identical result by subtracting our exponent. Either way, we get the same thing. However, on the right-hand side, right, if I rewrite this like so, we can see that we still have 2 x's that cancel out. However, those 3 leftover x's are where? They're not in the numerator anymore, are they? They're in the denominator. And again, if I used my quotient rule to subtract my exponents, I would not get x to the 3rd, I would get x to the negative 3rd. So if I'm using this approach here, which is absolutely fine and valid, then I have to do this extra step and rewrite it as 1 over x to the 3rd power if my directions say to express my answer using only positive exponents. So now we have x to the 6th divided by x squared. So again, I can have 6x's upstairs, one more x there, okay, and 2x's downstairs. Okay, again, these guys cancel out. So I have 4 leftover x's, and those 4 x's are upstairs. So we have x to the 4th power. Oops, sorry about that. And then again, I could have achieved the exact same result by simply subtracting my exponents using the quotient rule. Okay, however, on the other side here, right, if I have x squared divided by x to the 6th, we have a different result. Again, right, we still have 1, 2 x's that cancel out. However, right, where are our leftover x's? Well, they're in the denominator, not the numerator. And if I had applied the quotient rule, right, I get 2 minus 6, that is negative 4. So we get x to the negative 4th power. So if we want to use that, then we would have to do an extra step and rewrite it as 1 over x to the 4th power. So in general, okay, if I have any base to the negative m power, that's going to give me 1 over a to the m power. Okay, and conversely, I could, let's say that I start with something that looks like this, 1 over a to the negative m power. And remember, my directions are going to tell me, no, 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 that can't be your final answer. You have to rewrite it using only positive exponents. If that's the case, then I can rewrite it like this. Okay? So, let's do some more examples, slowly ease ourselves into this and get comfortable with the idea, the concept of negative exponents, rewriting them using positive exponents. Okay, so we have x to the negative 5th power. Again, this is a good time to pause the video, try these on your own, and then unpause it to see if you are correct. So pause the video and see if you can rewrite x to the negative 5th using these identities, these rules of negative exponents, and unpause it to see if you are correct. So I could rewrite x to the negative 5th power as 1 over x to the 5th power, okay? And when I do that, I'm using this rule of exponents. Number 2, y to the 2nd power. So I can rewrite this as 1 over y squared, okay? And when I do that, I'm using this rule of exponents here. Okay, then we have some more math, right? Y squared divided by y to the 10th. So I don't want to do all that multiplication. I'm not going to write y out 12 different times. I'm not going to bother with that. So instead, what I'm going to do is I'm going to apply the quotient rule. So we have 2 minus 10. Well, 2 minus 10 is negative 8. Again, we have to express our answer using only positive exponents. So y to the negative 8th we can rewrite as 1 over y to the 8th power. Okay. So again, we have some work to do. So this time, right, we have a little bit more work to do. So we can rewrite this as 3 over 6 times a to the 3rd divided by a to the 6th times 1 over b. Okay? So 3 over 6, right, that is just a fraction that we can reduce. We know how to do that. We've done that a million times. So that reduces to 1/2. Okay? Then we apply the quotient rule. So we have a to the 3 minus 6 power. Okay, and then since we want a positive exponent and there's not any math to do here, it's just 1 over b, I'm going to leave him alone. Okay, because if I change him at all, if I rewrite it as b to the negative 1st power, it's just going to give me more work to do later, and I don't need more work to do. Okay, so we have 1/2 times, well, 3 minus 6 is negative 3. Okay, so now the only thing left to do, the only thing left to fix, if as it were, is to rewrite a to the negative 3rd as 1 over a to the 3rd. Okay, so let's go ahead and do that. So we have 1/2 times 1 over a to the 3rd times 1 over b. So this is looking a little bit messy, so I'm just going to rewrite it as a single fraction. So our denominator is 2 times a to the 3rd power times b. So you have 1 over 2a cubed b. And that's your final answer. All right, now we have 5x to the negative 2nd power, y to the negative 1st power. Again, use your imagination, pretend you can see somewhere, because it's always going to say this. You have to write your exponents, you have to write your answer using only positive exponents. So let's take x to the negative 2nd power. Remember that can be rewritten as 1 over x squared. And then we have y to the negative 1st power is 1 over y. So we have 5 times 1 over x squared times 1 over y. If it upsets you that 5 is not a fraction, you could write it as 5 over 1. right? And then we have 5 times 1 times 1 upstairs, and we have 1 times x squared times y downstairs. So the simplest way to express this answer is 5 divided by x squared y. All right, so now we're finally getting into applying this rule right here, right? This is where it gets really interesting. So we have 1 over 7 times 1 over x to the negative second power, right? So the 1 over 7, like, he's fine. We don't have to mess with him. He's just chilling. What we do have to do, right, is we have to rewrite this using only positive exponents. So how are we going to rewrite 1 over x to the negative second power? Pause the video, see if you can figure it out on your own, and then unpause it to see if you were right. Okay? So the way we can rewrite this is 1 over x to the negative second power is x squared. Okay? So we're going to have 1/7 times x squared over 1, right? And then we can write this more simply as just x squared divided by 7. So this is the part of the video where I'm going to give you the cute little memory technique that I teach my students when I teach a face-to-face class. Okay? So I say, pretend you are a landlord, okay? And you have tenants, okay? And the apartment or the area that you own, right? You have the upper level, okay? And then you have your basement apartments. Okay? And what you want is you want everybody to be happy. In other words, you want everybody to be positive. So let's say you have, for example, something that looks like this. Okay, so all of your tenants are unhappy, meaning they all have negative exponents. So if he's living in that basement apartment and he's unhappy, right, because maybe he just really needs to feel the sun, then we're going to move him upstairs. And he's going to have when we move him upstairs, he's going to be happy, right? He's going to get a positive exponent. Then maybe this guy, he doesn't want sunlight. Maybe he's a vampire. I don't know. So since we want to make him a positive exponent, he's in the upstairs apartment. He's not happy. We're going to move him downstairs into the basement apartment, and he's going to be happy. So it's a silly little metaphor, but it kind of helps you remember, right? You're basically, when we have a negative exponent, we're moving it either from the numerator into the denominator or vice versa. All right, let's do a few more examples. So we can rewrite this as 1/2 times 1 over x to the negative first power times 1 over x to the negative third power. Again, you don't have to write it this way. This is just an easy way to break it down and create smaller, simpler problems out of one larger problem. Okay, so if I have 1 over x to the negative first power, so let's use our silly little metaphor, right? Remember, he's living in his basement apartment, but he's not happy. So to make him happy, so he keeps paying his rent, we're going to move him upstairs into the numerator. Now there's nothing in the denominator, right? But we can still put a 1 over here if it makes us happy. But we could also just write it more simply as just x. Up to you. Okay? So then we have 1 over y to the negative third power. Again, now we have this other guy. He's living in another downstairs basement apartment. He's not happy, right? We got to move him to the upstairs unit so he can get more sun. Okay, so now he's happy. He's y to the third over 1, or you could just write y to the third. Okay, so if we put that all together, we have 1/2 times x times y to the third power. That's totally fine to leave it that way. Another equally valid way to express the final answer is x y to the third power, or x times y to the third power, all divided by 2. All right, last but not least. Okay, now it's getting really fun because now we're getting into problems where we actually have to apply the product and the quotient rule and do things that we did in the first few videos where we learned those rules and we applied them. Okay, so again, remember I taught you in a previous video that all of these things are being connected through multiplication, and remember that multiplication itself is commutative, not commutative, but commutative, meaning that order doesn't matter. In other words, 2 times 3 is the same as 3 times 2. So I can use the commutative property of multiplication to rearrange these terms and make it a little bit more obvious how I need to proceed. So I'm going to put -2 and -3 times each other. Again, please don't forget what you knew before you met me, right? -2 times -3, type it in your calculator if you need it. It's going to get you +6. Okay, so then remember we're going to apply the product rule of exponents. The product rule of exponents tells us to add exponents when we're multiplying two terms with the same base. So we have 3 plus -5. Well, what is 3 plus -5? Well, it's -2. So I have 6x to the negative second power. And you might think, gee golly, I think I'm done. But remember, your directions on your homework, on your quiz, on your test are going to say, always write your answer using only positive exponents. So we have to rewrite this guy. Again, we have a tenant living in an upstairs apartment. He is fundamentally unhappy. Okay, so we're going to move him to our downstairs apartment. So one quick note here, I see this very, very, very often. Okay, I'm going to put this in ugly red color. Sorry, red is very beautiful, but hopefully it jumps out at you so that you can see that it is wrong. Okay, I see this a lot. 1 over 6x squared. Okay, what did I do wrong? What mistake did I make? See if you can pause this video, jot down or make a note, or make a mental note. What is wrong with this answer? Why is it wrong? And what should the right answer be? Okay, well, the answer is that this 6, right, there is nothing wrong with that 6. He is chilling. He is happy, okay? Do not mess with him. First of all, he doesn't even have an exponent, right? He's just a constant, okay? So I think we can agree that if I give you 6 pizzas, and if I give you 1/6 of one pizza, that is not the same thing, right? 6 and 1/6 are very, very different numbers. So you can't arbitrarily change out one for the other, right? That's cheating. You can't do that. It's not true. Okay, the only thing I can change is this x to the negative second power. Okay, so he's going to become x squared. Okay, to help yourself with that, you could rewrite it like this. So you can see that it's, oops, sorry. I wrote it wrong. Sorry about that. So that you can see that it's actually 2 problems in one, right? So if you just look at 6 over 1, it's very clear that 6 over 1 is just 6 over 1. We don't have to mess with him, right? What we do have to change, what we do want to mess with, is the x to the negative second power. And again, we can rewrite that as 1 over x squared. Okay, so be very, very careful, because probably at least once when you're working through these problems, you're going to be tempted to accidentally take one of the constants that's either already in the numerator and move them in the denominator, or take a number that's already in the denominator and move them into the numerator. And again, that's not, there's no reason to do that. It's not a valid mathematical operation. Okay, so please be careful with that.